When it comes to the most mysterious objects in the universe, the first thing that comes to mind are black holes, monsters that devour everything in their path. They bend space and time, turning light into an invisible prisoner. But what if there is the exact opposite of these monsters, something that does not consume, but erupts matter? White holes are one of the strangest and least understood concepts in astrophysics. According to Einstein's equations, if black holes exist, then white holes must also exist. But why can't we see them? What is a white hole and how is it different from a black hole? Why does its existence challenge our picture of the universe? Could a white hole be a portal to another reality or even the other side of a black hole? This topic raises so many questions that if they are true, we'll have to rewrite the whole cosmology. What is a white hole? In 1916, Karl Schwarzschild, studying Einstein's equations, derived a solution for the space-time curvature around a massive object. It described two possible solutions. A black hole, ordinary an object with such strong gravity that nothing can escape beyond its event horizon. A white hole, an object from which nothing can get in, but is only ejected outward. If a black hole works like a cosmic trap, a white hole works like an eruption. Simple analogy. A black hole is the drain hole in the bathroom where the water goes in. The white hole is the faucet where water pours out with no way to flow back in. But this is where the problem comes in. We can see black holes, for example. Their shadow is captured by the Event Horizon telescope, but white holes are not. Why? Why can't white holes be seen? There are several theories to explain this paradox. 1. White holes are unstable. If black holes form when a star collapses, then the reverse process, the explosion of a white hole, is impossible. Any particle, even light, cannot enter a white hole. But how then is matter formed inside it? 2 white holes exist, but they're hard to see. They can live very short lives. For example, they can appear and disappear instantly, emitting huge streams of energy. We may have seen such phenomena before, but interpreted them as powerful gamma-ray bursts. 3. They may be hidden inside black holes. If white holes are connected to black holes, they may exist in another space or dimension, ejecting matter there. This leads us to the craziest question ever. What if black holes are entrances and white holes are exits to another part of the universe? White holes as portals to other worlds. One of the most fascinating aspects of white holes is their connection to wormholes. A wormhole, or Einstein-Rosen bridge, is a hypothetical tunnel connecting 2 different points in space-time. If a white hole is an exit and a black hole is an entrance, then they could work as a portal. What does this mean? Perhaps matter trapped in a black hole does not disappear forever, but is ejected to another part of the universe through the white hole. This could explain the sudden bursts of energy in some parts of space. Maybe universes are connected to each other through black and white holes, creating a multidimensional web of spaces. But there's a catch. Wormholes are theoretically unstable. They should collapse instantly, or exist only in the presence of exotic matter. White holes and quantum physics. If white holes exist, they must be described not only by general relativity, but also by quantum mechanics. One hypothesis states that white holes are the final stage of black hole evaporation. When a black hole loses mass due to Hawking radiation, it can eventually explode and become a white hole. This may explain rare superenergetic cosmic flares. Other hypotheses. White holes may be related to the information paradox. Perhaps information about absorbed objects is released through the white hole. They may be a source of dark energy affecting the accelerated expansion of the universe. Can white holes be detected? There are several ways to find them. 1. Look for superenergetic emissions, for example, gamma-ray bursts whose origin is still unclear. 2. Look for strange gravitational effects. Perhaps white holes create strange disturbances that can be detected. 3. Looking for inverse black hole effects, something that behaves in the opposite way. Future telescopes like the James Webb Space Telescope or next-generation gravitational observatories may give us the answer. If white holes exist, the universe is not at all what we thought. White holes could be the key to unraveling the most complex questions in physics. They could confirm the existence of moleholes and the multiverse, explain the disappearance of information in black holes, become a bridge to understanding quantum gravity. Imagine if we ever find a white hole, a portal to distant worlds. And now a question for you. Do you think white holes exist, or is it just pretty math? Write it in the comments. White holes are one of the most mysterious and explosive ideas in modern physics. If they really exist, it would literally revolutionize our view of the universe. Why are white holes so important? They break the usual laws of physics. White holes, in theory, do not absorb, but eject matter. This contradicts the second law of thermodynamics, which says entropy chaos must always increase. They can explain the Big Bang. Some physicists speculate that our Big Bang could have been a white hole from another universe. This means that our universe is just part of an endless chain of birth and destruction. They may be connected to the multiverse. If black holes are connected to white holes, it could mean that they create tunnels between different universes. They could be the key to quantum gravity. There is no theory in modern physics that unites quantum mechanics and gravity. White holes could be the bridge that helps connect these two systems. Why can't we see them? White holes, according to Einstein's equations, should only exist in reverse time. This means that if they were in our universe, we would never be able to see the moment of their creation because they appear as pre-existing objects. But here's something that begs the question. Maybe white holes exist for a very short period of time, eject matter, and immediately disappear. Maybe some quasars and gamma-ray bursts are white holes, but we don't realize it yet, or white holes are hiding behind the event horizon of black holes, and we just don't know how to look for them properly. The future of research. Right now, we have no direct evidence for the existence of white holes. But technologies like gravitational detectors, X-ray telescopes, and quantum computing could bring us closer to the truth in the coming decades. If white holes exist, it will change everything. It would be a real explosion in astrophysics that could lead to a new theory of the universe. My prediction? I think that within the next 20 to 30 years, physicists will find evidence of white holes or their analogs. Perhaps we will realize that they are not just a mathematical abstraction, but a real part of the cosmic structure. What if they don't exist? Even if white holes turn out to be just a theory, studying them is already moving physics forward. After all, in order to prove that something doesn't exist, you need to understand very deeply the very nature of reality. Either way, white holes are a topic that will be on the minds of scientists for a very long time to come. If you liked this video, give it a like, subscribe, and get ready for new discoveries.